Databases are a great help in putting together the pieces of data that we hold. You will be able to organize your data so that you can easily extract information. This course will teach you how to work with databases. Hello everyone, welcome to Database Programming. This is Miss Karen, and for this lesson, we will talk about the fundamentals of a database system. First, we will talk about what you will learn in this module. At the end of the lesson, you should be able to differentiate data and information, define what database is, the various types of databases and why they are valuable assets for decision making, and appreciate the practical use of databases in daily life. Data. Data are building blocks of information. Data in a context of databases refers to all the single items that are stored in a database, either individually or as a set. For example, in a banking application, data is the whole collection of bank account numbers, bank customers' names, addresses, ages, and bank transactions, and so on. Can you give examples of data? Data are everywhere. It can be weight, price, cost, numbers of items sold, student names, teachers' names, addresses, tax codes, registration marks, and grades. In this table entitled Students, can you identify the data given? Yes, you are correct. These are ID, first name, last name, email, and year of birth. Information. Information is defined as the data that have been processed. Being presented with this mass of data will simply overwhelm the average human. An individual simply cannot process it all. However, when data is arranged relationally, it then becomes information, which is much more useful to the users. For example, if the mass of numbers stored in the banking database above is used to extract the names and addresses of the top 100 clients by the size of deposit, then the data has been used to provide useful information. Can you give examples of information? One example is the grades obtained by students and their roll numbers. This is in the form of report card or sheet. Other forms of information are payslips, schedules, reports, worksheet, bar chart, invoices, and account returns. The diagram on the right side shows the information processing cycle. This happens when data is collected and given to the computer for processing. Computer processes data to the required information, and then information is given to the users as output. And then later, information is stored in the computer for further use. Metadata are data that describe the properties or characteristics of other data. Some of these properties include data definitions, data structures, and rules or constraints. Metadata allow database designers and users to understand what data exists, what the data mean, and what are the fine distinctions between seemingly similar data items. In this table entitled 2016 Sales, the metadata are the columns month, forecast, sales, and variation. What is a database? A database is a collection of data that is used by the application systems of some given enterprise. It is a shared, integrated computer structure that stores a collection of end-user data. These are raw facts of interest to end-user. And metadata. These are data about data. It provides description of data characteristics and relationships in data. Databases are used to store, manipulate, and retrieve data in nearly every type of organization including business, healthcare, education, government, and libraries. Database components. A database contains one or more schemas, which is a collection of one or more tables of data. Table. Each table contains multiple columns which are similar to columns in a spreadsheet. Column. Each column contains one of several types of data or values, like dates, numeric or integer values, and alphanumeric values. And lastly, we have row. Data in a table is listed in rows, which are like rows of data in a spreadsheet. Often, there are hundreds or thousands of rows in a table. These are the applications of database in our day-to-day life. In banking, it involves all transactions. In airlines, it involves reservations and schedules. In universities, we have registration and grades. In sales, it involves customers, products, and purchases. In manufacturing, it involves production, inventory, orders, or supply chain. We also have human resources, employee records, salaries, and tax deductions. A database is composed of tables. Each table is composed of records. Each record is composed of fields. This is the hierarchy of data in a database. It is the way the contents of the database are organized. If we are going to relate it to the file system, a database is like a filing cabinet drawer that contains several folders. Tables in a database are like folders in the drawer. They deal with the different aspects of the database. The documents in a folder are like the records in a database table. Just as the document has several parts, a record can also be broken down into fields. These are the terminologies you will encounter in this course. Data are raw facts, such as telephone number, birth date, customer name, and the year-to-date sales value. Data have little meaning unless they have been organized in some logical manner. Fields are character or group of characters, which is alphabetic or numeric, that has a specific meaning. A field is used to define and store data. Record, a logically connected set of one or more fields that describe a person, place, or thing. For example, the fields that constitute a customer record might consist of the customer's name, address, phone number, date of birth, credit limit, and unpaid balance. File is a collection of related records. For example, a file might contain data about the students currently enrolled at a gigantic university. History of database. In 1960s, a little later than the first application of computers in business, back then, each computer maker sold data collection software with the machine. In 1960, Charles Backman designed the first DBMS system. In 1970, Dr. Edgar F. Codd published an academic paper on relational databases. His article inspired the creation of language to handle database transactions called the SQL, or the Structured English Query Language. The word English was later dropped, and the language was standardized to SQL, or the Structured Query Language. An SQL is a way of giving the computer instructions on how to handle large volumes of data. Codd also introduced IBM's information management system during this year. In 1976, Peter Chen coined and defined the entity relationship model, which is also known as the ER model. The ER model is used in database designing. In 1980, relational model becomes a widely accepted database component. In 1985, object-oriented DBMS develops. In 1990s, incorporation of object orientation in relational DBMS, and in 1991, Microsoft ships MS Access, a personal DBMS, and that displaces all other personal DBMS products. 1995, it's the first internet database application. In 1997, XML applied to database processing. Many vendors begin to integrate XML into DBMS products. Today, some of the current relational databases include giants such as Oracle, MySQL, and DB2. The most used DBMS today is MySQL. What is a database management system? DBMS is a software for storing and retrieving users' data while considering appropriate security measures. It consists of a group of programs which manipulate the database. The DBMS accepts the request for data from an application and instructs the operating system to provide the specific data. It is the intermediary between the user and the database. Roles and advantages of DBMS. The first one is improved data sharing. An advantage of the database management approach is the DBMS helps to create an environment in which end users have better access to more and better managed data. Such access makes it possible for end users to respond quickly to changes in their environment. Next is improved data security. The more users access the data, the greater the risk of data security breaches. Corporations invest considerable amounts of time, effort, and money to ensure that corporate data are used properly. A DBMS provides a framework for better enforcement of data privacy and security policies. Next, we have better data integration. Wider access to well-managed data promotes an integrated view of the organization's operations and a clearer view of the big picture. It becomes much easier to see how actions in one segment of the company affect other segments. Next is minimized data inconsistency. Data inconsistency exists when different versions of the same data appear in different places. For example, data inconsistency exists when a company's sales department stores a sales representative's name, such as John de la Cruz, and the company's personal department store that same person's name as Peter de la Cruz. The probability of data inconsistency is greatly reduced in a properly designed database. Next is improved data access. The DBMS makes it possible to produce quick answers to ad hoc queries. From a database perspective, a query is a specific request issued to the DBMS for data manipulation. Next is improved decision making. Better managed data and improved data access makes it possible to generate better quality information on which better decisions are based. Next is increased user productivity. The availability of data combined with the tools that transform data into usable information empowers end users to make a quick, informed decisions that can make the difference between success and failure in the global economy. In this image, can you explain how DBMS interacts between the end user and the database? Comment your answers in the comment section below. The database is categorized into three types. First is the number of users, its database location, and the expected type and extent of use. According to the number of users, there are two types of database. First is the single user and multi-user database. The single user supports only one user at a time. Examples of these are desktop databases that runs on PC. We also have the multi-user database which supports multiple users at the same time. This is the database that is used in workgroup or in enterprise. According to database location, there are two subtypes. First is the centralized database, and the other is the distributed database. A centralized database is stored at a single location, a mainframe computer for instance. It can be accessed, maintained, and modified only from that location. A distributed database is the term used to describe a set of databases stored on multiple computers, but that present as a single database to all the users. According to the expected type and extent of use, we have the operational database. Operational database supports a company's day-to-day operations. Examples of these are transactional and production databases. An example of transactional is a human resource database that includes data identifying each employee and his or her time worked, training, and development status. Let us go now with the types of relational DBMS. MariaDB, MS Access, MS SQL Server, IBM, MySQL, and Oracle are some of the top relational database management systems. Each RDBMS is categorized according to their type of database. In this course, we will focus on MySQL, which is an open-source relational database management system. The database system environment. The database system defines and regulates the collection, storage, management, and use of data. There are 5 major parts of a database system. First is the hardware. The hardware are all the system's physical devices. In software, there are 3 types of software required: operating system software, DBMS software, and application programs and utility software. We also have people. These are all users of the database system. It consists of system and database administrators, database designers, systems analysts and programmers, and end users. We also have procedures. These are instructions and rules that govern the design and the use of the database system. Lastly, the data is the collection of facts stored in the database.